Hi everyone, and welcome to this session. It is great to be back at Scomathon again this year. My name is Mark van der Veer, and I am a product manager and consultant at Gripmatics. And in this session, I want to walk you through how monitoring needs to evolve as organizations move from VMware to Hyper-V. And more specifically, how the Hyper-V SCOM Extension Management Pack fits into that. I will also show you what's new within the latest version of this extension management pack, and more importantly, what that actually means in day-to-day operations. So here is a quick overview of what we will be covering today during this session. So first, we will have a look at what's currently changing within the virtualization landscape and why that actually matters. Then we'll go into some of the monitoring challenges we typically see within Hyper-V environments. And after that, I will briefly touch on the current state of the Microsoft Hyper-V Management Pack. From there, we'll move into the Hyper-V Extension Management Pack, what it is, where it comes from, and how it evolved over time. And finally, I will walk you through a demo so you can see how this looks within a real environment. So, why is this topic relevant right now? Well, over the past couple of years, we've seen more and more organizations reassessing their VMware strategy. And this is mainly driven by the Broadcom acquisition of VMware in late 2023 and the changes that followed after that. So, one of the key changes has been the shift from perpetual licensing to a subscription-based model. So, that basically means customers are no longer able to buy permanent licenses and use them long term, typically together with annual support renewals. But instead, they are now required to move to a subscription-based model. And at the same time, the licensing model itself has also changed quite significantly. For example, licensing is now more strictly tied to CPU core counts, with a minimum core requirement for each physical CPU. And that might sound like a small detail, but in practice, it has a really big impact because today's modern servers have a lot more CPU cores than they used to have. So even without changing the infrastructure, the VMware licensing costs can increase significantly. In addition to that, many standalone VMware products have now been bundled into larger packages, which means organizations sometimes actually license more than they actually need. So as a result of all these changes, many organizations have seen significant price increases, in some cases even multiple times higher than before. And what we see in practice is that virtualization strategy is no longer just a technical decision, but it became a business decision driven by cost, flexibility, and long-term strategy. So as a result, many VMware organizations are starting to exploring alternatives. And one of the platforms we see coming back into focus is Hyper-V. But when infrastructure changes, it's important for monitoring to evolve alongside it. Because if it doesn't, you risk losing visibility into what's actually happening within your hypervisor environment. So Hyper-V is one of the platforms organizations are moving to, but it's definitely not the only option. For example, when you're using Citrix, Xen Server is included as part of the subscription with no additional license costs. So it's often the go-to option within Citrix environments because it also integrates very tightly with Citrix and it's optimized for Citrix workloads, while still being perfectly suitable for non-Citrix workloads as well. From a monitoring perspective, there is a native SCOM management pack available, Metrics Insight for Xen Server from Gripmatics. For Hyper-V based deployments, you typically rely on the Microsoft Hyper-V Management Pack, extended with the community-driven Hyper-V Extension Management Pack, which is what we'll be focused on today during this session. So regardless of the platform, the key question becomes, how do you maintain consistent visibility as your virtualization strategy evolves? And this is where things often become challenging. Because when migrating to another hypervisor platform, the focus is usually on moving workloads, compute, storage, networking. That's where most of the attention goes to. But what often gets less attention is everything around it. Integration, automation, and especially monitoring. Because monitoring is often assumed to just continue working, right? But in reality, well, that's not always the case. And if monitoring isn't properly addressed as part of the migration, you can end up with a visibility gap. And that typically only becomes apparent once you're already running production workloads on your new hypervisor environment. So what we mostly see in organizations that have moved to Hyper-V is the following. The platform itself is up and running, the workloads are migrated, everything seems to be in place, with SCOM already up and running. So from a project perspective, everything is considered done. But then, once things are in production, the reality starts to kick in. Because monitoring wasn't the main focus during the migrations. So visibility at the virtual machine level is limited. Correlation between host and VMs is not always clear. And alerts often lack context. So when something happens, you don't immediately know where to look. Is it the virtual machine? Is it the virtualization host? Or is it something shared underneath? And that uncertainty slows everything down. As a result, troubleshooting becomes more time consuming than it should be. And what often happens is that teams start relying on manual checks again just to understand what's going on. So let's take a look at the Hyper-V Management Pack. This is the official management pack provided by Microsoft, forming the foundation for monitoring Hyper-V within SCOM. It was originally designed for Windows Server 2016 and Windows Server 2019, and it provides some host level monitoring along with some basic virtual machine help. So it gives you a solid starting point for monitoring Hyper-V. But it's important to keep in mind that it was designed for a different time, when environments were less dynamic than they are today. So the good news is that the Microsoft Hyper-V Management Pack continues to work well on more recent Hyper-V platforms. Hyper-V 2019 is the supported baseline. Hyper-V 2022 is supported as well. And Hyper-V 2025, well, we have validated that it works without any issues. The discovery works as expected, workflows are running well, and the help model behaves consistently. So from a compatibility perspective, there are no concerns. But while the management pack works well, the level of insight it provides is still quite limited for modern environments. Performance visibility is fairly basic. The topology awareness is limited, and alerts often lack the operational context needed to quickly understand what's actually happening. And what that means in practice is that you still have to do a lot of interpretation by yourself. So when an alert comes in, you often still have to ask yourself, what is actually causing this? Is it a VM issue? Is it something happening on the host? Or is it something shared, like storage or resource contention? And because that relationship isn't always clear, you end up navigating through multiple views, checking different objects, and trying to correlate things manually. So instead of quickly understanding what's going on, you're spending time figuring out where to look. So while it gives you a solid foundation, it doesn't always provide the depth needed for effective day-to-day operations. And that's exactly where the Hyper-V Extension Management Pack comes in. So the Hyper-V Extension Management Pack is a community-driven extension built on top of the Microsoft Hyper-V Management Pack. So it doesn't replace anything, but it enhances the existing monitoring. The Extension Management Pack was originally created by Diego to address real-world monitoring gaps within Hyper-V environments. And that's really the key idea behind it. Not to redesign monitoring, but to make it more usable and more insightful in day-to-day operations. And over time, the extension has evolved through contributions from the community to improve visibility and operational insight. If we look at how this extension has evolved over time, it actually has quite a long history. It started back in 2013 with support for Hyper-V 2012, and it was created by Diego and further developed together with Christian Edwards. In 2018, it was extended to support Hyper-V 2016 with additional monitoring capabilities. Then in 2019, support for Hyper-V 2019 was added by Marijn Overgouw, including more performance insights across different layers. And more recently, it has been modernized to support current Hyper-V versions, with contributions from Gridmedics to bring it up to modern Hyper-V environments, along with improvements in visibility and usability. So, building on that evolution, let's take a look at what's new in this latest release. Well, first of all, support has been extended to modern platforms, including Hyper-V 2022 and Hyper-V 2025. In addition, new dashboards have been introduced for both Hyper-V hosts and virtual machines. And this is really where things become more practical, because these dashboards are really about making information more accessible. Because instead of navigating through multiple views, clicking through different objects, and trying to piece information together, you get a more consolidated picture of your environment using the dashboards, making it easier to understand what's going on at both host and virtual machine level. And overall, there have been various enhancements and optimizations to improve the visibility and usability of the extension management pack. And that ultimately translates into real operational benefits. It provides better visibility across both hosts and virtual machines, giving you a clearer understanding of how your environment is behaving. It enables more insights into what's actually happening rather than just reacting to alerts. And it helps reduce the time it takes to troubleshoot issues. So, how about we switch over to the demo environment and take a look at how this works in practice. All right, so now I will walk you through the Hyper-V Extension Management Pack from an operational perspective. So let's first start by looking at the environment. I've opened up the SCOM console here in our environment, and as you can see, we have a total of 3 Hyper-V hosts. The Hyper-V 01 is running Windows Server 2025. Hyper-V 02 is running Windows Server 2022. And Hyper-V 03 is running Windows Server 2019. So in a typical production environment, you would be running the same Hyper-V versions across all hosts. But during upgrades or migration scenarios, mixed environments like this are actually very common. So today we are using this setup to show you that the Hyper-V Extension Management Pack works consistently across different Hyper-V versions as well. So even in mixed environments, you still get one consistent operational view. So before we move into the dashboards, I want to briefly highlight the disk state views. So if I go to the logical state section, the logical disks shown here are discovered and monitored by the Microsoft Windows Server Management Pack. And these views are embedded within the Hyper-V Extension Management Pack. So this brings together Microsoft's core monitoring and Hyper-V insights into a single operational view. So the logical disk represents the volumes that are used by the Hyper-V operating system. And this helps us to monitor the capacity, the volume health, and the available space. If we click on the physical disk state section, it will show the underlying physical disks within the Hyper-V host. And this helps to detect hardware level issues like disk failures or degraded storage. So actually we are combining native Windows monitoring with Hyper-V insights into one place. So with that in place, let's move into the dashboards. So we will start first with the host dashboards. So I will click the host dashboards. And here you see again the three Hyper-V hypervisor hosts. And from here I can just click on a specific hypervisor host. And on this host level, it will give us the operational overview of the hypervisor layer. So right away, we can see which hosts are healthy or which hosts might need attention. So one important thing here is that we can also select multiple hosts at the same time. And based on that selection, the dashboard shows a consolidated view. So both the performance graphs and the alerts are aggregated across the selected host. So if I just select the Hyper-V 01, we can see here in this section the CPU performance metrics. And it's actually split between the virtual machine workload CPU usage and the hypervisor CPU usage. So it gives a glance overview about how much CPU is working on the hypervisor runtime, basically the hypervisor overhead costs, and the CPU that is actually being used by the virtual machines running on this particular Hyper-V host. So this helps answer a key question. Is the CPU load coming from the virtual machines or from the hypervisor itself? Now let's have a look at these alerts. I see here an alert mentioning something about the dynamic memory. So before we dive into this alert, I think it's important to briefly explain how dynamic memory works within Hyper-V. So with dynamic memory, each virtual machine is configured with a startup amount of memory and a maximum amount of memory that that particular VM is allowed to use. So the VM doesn't always use its maximum. It actually only consumes dynamically what it actually needs. So this allows the host to assign more total memory across all the virtual machines than the physical memory available within the host. And that is called overcommitting. So this alert tells us that the total configured maximum memories across all the VMs exceed the physical memory on the host. So that doesn't really necessarily mean that the host is out of memory, but it means that if all the VMs request their maximum memory at the same time, this particular host wouldn't be able to satisfy that demand. So it's actually not a current issue, but it's more like a capacity risk. So the next question would be, is this risk actually happening now? And the nice thing about this dashboard is that we can immediately answer that question directly from here. Because this specific graph shows the actual memory pressure on this specific Hyper-V host. So in this case, we are around 70 to 75%. So even we are overcommitted, everything is still operating normally. And that shows the difference between a configuration risk and actual behavior. So as a guideline, 60 to 80% is in general a healthy situation. If it becomes above 80%, then it is advisable to closely monitor the memory usage. But if it goes about 90%, then we might take some action by, for example, increase the amount of memory within the Hyper-V host, or maybe reduce some memory on virtual machines. So you will also notice that we already see some alerts coming from the virtual machines that are running on this particular Hyper-V host. And that is because the virtual machines are child object of the host. So let's have a closer look at those from the virtual machine dashboards. So here we are at the virtual machine dashboard. And it gives a nice overview of all the virtual machines that are running on the various Hyper-V hosts. And it also immediately indicates which particular VMs need some attention or which VMs are running healthy. So also in this section, I can just select one particular VM, and then it will show me some various key performance metrics here on the right side, and it will show the active alerts that are applicable to this particular virtual machine. And also within this dashboard, I can select multiple virtual machines at the same time. So all the data is being plotted together within the dashboard. So let's just have a look as an example on this particular virtual machine. So here on the right side, we see some performance metrics regarding the virtual processor that is being used by this virtual machine. So it is actually split up in two sections. One section is the guest runtime. So that's basically the amount of CPU that this VM is actually using, and the amount of hypervisor runtime, which is basically the virtualization overhead on the hypervisor host layer for this particular virtual machine. So with this data, we can immediately see if the virtual CPU usage is mainly coming from the virtual machine itself or the hypervisor overhead. Then on the right section, we see some key performance metrics regarding the virtual hard disks. So the virtual hard disk queue length shows how many I/O operations are currently waiting, and the latency shows how long those operations take. So in my opinion, I think the disk latency is the most important one to monitor, because disk latency heavily affects the user experience within that virtual machine. Because if a virtual disk is very slow in reading or writing data, it will affect the performance of the virtual machine very badly. It will feel sluggish and it will slowly respond. So in general, as a general guideline, everything below the 5 millisecond is excellent. Between the 5 and 20 milliseconds is in general considered acceptable, and above the 50 milliseconds, it really becomes an issue. So these metrics we see here are essential for understanding the virtual machine performance and identifying the root cause of issues. So let's have a look at the alerts that are currently active for this particular virtual machine. So this alert actually tells us that this particular VM effectively hit its memory limit. So that means it is already using its maximum configured dynamic memory. So this particular VM is asking for more memory, but it cannot receive any additional memory because it has reached its configured maximum. So a possible next step would be to increase the maximum dynamic memory for this virtual machine. But of course, this needs to be evaluated in the context of the hypervisor host, whether sufficient physical memory is available. So that ties directly back to what we saw earlier at the host level, within the host level dashboard. So It is important to balance the virtual machine requirements with the overall host capacity. So let's have a look at another alert. Here we see a warning indicating that a snapshot exists on the virtual machine, or in Hyper-V terms, a checkpoint exists. So a checkpoint is typically used to create a rollback point before making any changes within a virtual machine. So for example, if you want to update some software within a virtual machine or do some operating system patching, um, you can create a checkpoint. And if something goes wrong in that process, you can easily revert back to the virtual machine state as before you were making those changes. So it is very useful for short-term protection. However, please be aware that snapshots or checkpoints cannot be used as a backup because a snapshot always relies on its parent disk, because a snapshot is basically a differencing disk on top of the virtual hard disk of the Hyper-V machine itself. So it can only be used for short-term protection. So what I really like about monitoring snapshots is that snapshots are typically something that are being forgotten. So a snapshot is made, someone is doing some maintenance on that virtual machine, and it happens a lot of time that people forget to remove that snapshot after they finish their maintenance jobs on that virtual machine. So the problem is not really the snapshot itself, but when it's left into place and it's being forgotten. Because over time, that differencing disk of that snapshot can grow, it can impact performance, and increase complexity. So snapshots should always be removed after the virtual machine change has been completed. So that is exactly why the monitoring of snapshot usage is so important. So the snapshots are not going unnoticed. So next to the virtual machine dashboard, there are some other interesting performance views we can have a look at. So for example, here we can see the dynamic memory for the virtual machines. So for each VM, it will show you the physical memory, and it will show also the average pressure. So how many of that memory is actually being used within that VM. So here you can go more in depth if you need additional context regarding memory usage of a virtual machine. Also, this one is pretty interesting, I think. Here you can see more in depth the virtual processor usage. So next to the guest runtime and the hypervisor runtime, you can also see the total runtime. So for example, I see here the Hyper-V 01, and I can plot the other metrics also in the same graph. So it shows the total CPU runtime, and it also splits out the hypervisor runtime, which you can see here in the green section, and the blue section, which is the amount of CPU time used by the virtual machines running on this hypervisor. And together they form up the total hypervisor runtime available. So that concludes the demo for now, where I have demonstrated the value of the latest Hyper-V Extension Management Pack, and especially with the brand new dashboard introduced in this latest release, I think they provide a strong addition for providing better visibility and enabling faster, more targeted troubleshooting. So just for your information, this latest version of the community pack is available for download via the website gridmedics.com. So please feel free to grab a copy to use it by yourself. Well, thank you very much for attending this session, and I hope you have a great day here at SCOMathon.